Welcome back to the course on computer networks and internet protocols. So today we are going to start a new topic which we call as the network quality of service. So in this introductory lecture of the internet quality of service, we will first look into what is quality of service and what do we require quality of service. Indeed, in today's network, quality of service is a very important topic. Because nowadays we are going to use different kind of multimedia data and multimedia traffic, like we use mobile phones, and in mobile phones we have thousands of myriad different apps or applications which are running there, and we do different kind of multimedia based applications like this YouTube app, Facebook Live, then this Hotstar, Netflix, all these different type of applications which use multimedia streaming of data. So, this streaming data, the nature of streaming data is much different compared to the nature of normal file transfer. Why? Because in case of normal file transfer, you just need to transfer the bytes or the bits at the other end, and in the other end you can just combine all the bits all together whenever you are receiving or whether you have received all the bits, and then you can reconstruct the file. But in case of multimedia streaming, say just think of the example of YouTube streaming. Say for example, when you are watching this video, during that time the data is coming over the internet. So, and you are playing it simultaneously. So, do not think about the offline video download that playing, that is a different ball game, that is similar to that file transfer. You are just transferring the video file and playing it offline, but whenever you are playing it online over say YouTube, during that time from the YouTube server to your client which is running at your browser, the video data is getting transmitted continuously, and by the time this video data is getting transmitted, during the same time you are playing the video. And many of the time I think you have observed that whenever your network quality is poor, you do not have sufficient bandwidth, you may observe a degradation of the video quality. Suddenly you will see that the video quality is getting dropped, or sometime you may observe some events what we call as the rebuffering. So, what happens that the video got stuck and you keep on seeing the circular thing that is rounding about for trying to download the video data. Now, for this kind of video transmission, we need to maintain certain level of quality of service in the sense that what the other end or the client side is expecting from the internet. So, here in case of this YouTube video streaming, the client side, the YouTube client, it is expecting a continuous stream of videos such that it can render the videos directly on the player and play the video without having this kind of quality drop or rebuffering. So, that is why, or to ensure such kind of application quality, we need to provide certain special services at the internet level. Now, remember that providing this kind of special service over the internet requires something like a dedicated line or a dedicated resource that is given to you. So, do not get confused over the fact that while you are observing the videos over YouTube, why you are not able to see it properly whenever your video is getting bandwidth, whenever your network bandwidth is getting dropped, or whenever you see some quality degradation. That is because your network bandwidth on which you are currently subscribed, that does not provide that kind of service level agreement that you require to get the network quality of service. Now, today we will look into briefly that what type of quality of service parameters are required for this kind of smooth video streaming, or to improve the quality of service, or in other words sometimes we call it as quality of experience. The term quality of experience actually indicates the user's perceived quality of a particular application. So, for example, how good you are thinking about the video streaming service or the quality of the video that you are observing in YouTube. So, on that the network need to provide certain services so that you can look into those videos more smoothly, and obviously for that you have to pay more to your network service provider, and you have to go for an agreement with your network service provider that you require this particular types of video quality of service, and the network service provider should provide you that level of quality of service. So, this gives you a kind of broad overview of what quality of service actually means. Now, let us go into the details of different parameters which we need to play with while providing quality of service to the end users from the network perspective, and how we can ensure it over a large internet. Indeed, at the beginning of the lecture, let me give you an information that in today's internet, providing quality of service is indeed a very challenging task considering the scale of the network. So, that is why we actually apply certain kind of approximation there, and you will never get a perfect quality of service unless you have a dedicated leased line connection where you are getting the entire bandwidth. But for a general internet, for a general data transfer over the internet, we try to provide certain level of quality of service. So, let us look into the details of this particular topic. Okay. So, to start with our journey on quality of service, we start with this specific question that does this TCP congestion control ensures no congestion in the network? So, our objective is to see that whether this TCP congestion control algorithm ensures that there will be no congestion in the internet. Unfortunately, if you look into the TCP congestion control algorithm in details, what TCP does, TCP tries to avoid congestion. So, in other words, what TCP does, whenever TCP detects that there is certain congestion in the internet, during that time TCP simply finds out the reason for congestion. That means whether you have exceeded the slow start phase and you are observing certain kind of packet loss due to congestion, and TCP simply reduces its rate. And because of that, what TCP does, or the TCP congestion control behavior, it is like that once the congestion happens in the network, TCP detects it, and then only TCP responds to the congestion by reducing the sending rate of the sender. So, that way you are actually never avoiding the congestion in the network. Rather, what you are trying to do, you are trying to have congestion in the network, and then once congestion happens in the network, you are trying to coming out of that congestion scenario. So, TCP congestion control algorithm does not ensure that congestion will never happen in the network. Rather, it works in a different way, like it first finds out whether there is certain congestion in the network by observing the packet loss, and if there is congestion in the network, then only it acts or it updates its sending rate to avoid the congestion from the network. Now, the question comes that if there is still a possibility of congestion in the network, how this congestion impact the network performance. So, we look into 4 specific parameters on top that impact the network performance when there are congestion in the network. The first parameter is the network bandwidth. Obviously, whenever the congestion is there, you are expecting less bandwidth from the network, because the same bottleneck bandwidth is getting shared by multiple applications. The second parameter is the delay. We will look into the different components of delay in details, and we will see that whenever the congestion is there in the network, during that time the delay gets impacted. Like if there is a congestion, that means the packet need to wait for more amount of time in the packet buffer. Because the packet needs to wait for more amount of time in the packet buffer, you will experience that the packet will be transmitted with a higher delay, because the queuing delay, the time to wait inside the queues at intermediate routers, that gets increased. The third parameter which we are going to talk about, we call it jitter. So, possibly you have heard about this term bandwidth and delay earlier, but jitter may be a new term for you too. So, but in respective of quality of service, jitter is a very important parameter. So, what is jitter? So, jitter is basically the variance of delay. So, we call the variance of delay as the jitter. So, what do we mean by variance of delay? So, variance of delay means assume there are two packets which are coming from the or which are going through the network. So, whenever there are two packets which are going through the network, so assume that these are the sequences of packets which are being transferred over the network. Now, individual packets will have individual delay. So, say this first packet has a delay of 10 millisecond, that means you have a source here, you have a destination here, and from this source to destination there are multiple routers, and over that you are transferring these packets. Now, whenever you are transferring these packets, during that time these different packets may have different delay. So, say that this packet has 10 millisecond delay, this packet has say 15 millisecond delay, then this packet has say 6 millisecond delay, and this packet expects some say 2 millisecond delay. Now, why there is a variance here? So, what you can see from here that the variance of delay among those 4 packets is significant, like the maximum delay is something like 15 millisecond and the minimum delay is something like 2 millisecond. And why there can be variance? Because different packets may experience different level of congestion at the intermediate routers. So, it may happen that whenever these first 2 or 3 packets were getting transmitted, during that time you had the congestion in the network, and as a result, due to this congestion the packets have experienced more waiting time inside the packet queues at these intermediate routers. But this last packet, it came out of the congestion, and because it was able to came out of the congestion through the TCP congestion control algorithm which is running at the transport layer. So, maybe at this point of time TCP has experienced or TCP has found out a packet loss, and whenever TCP has found out a packet loss, TCP has reduced its rate, and as the TCP has reduced its rate, the congestion will slowly get out of the network and you will see less delay. But this delay variation among multiple packets, that actually impact the performance or the quality of video streaming services. Now, the question comes that how it impacts the quality of video streaming services. Just think of the scenario when you are observing a video in a YouTube player, and during that time every data packet is coming one after another, that is getting buffered inside the client buffer that you have at the YouTube player, and then the YouTube playering is rendering that video. Now, if different packets has different delay, then the problem is comes for the live streaming. So, for the live streaming, what happens, whatever I am doing here or whatever I am say recording here, that is getting streamed immediately. So, currently you are observing something called a buffer streaming, because the video has been recorded and you are getting the video from the video server. But if there is a live streaming session, just think of an NPTEL live streaming session which is going on. Now, in that live streaming session, whenever some video is getting recorded, immediately that video is getting transferred, and that video is getting played in the YouTube player where you are being observed. Now, if different data packets has different amount of delay, what will happen? Some packets will reach there at the client side and the client will play it, then the next packet comes. So, the next packet has say a higher delay. So, the client wait for some amount of time and plays it. Again the third packet say it comes very fast. So, the client plays it immediately. The fourth packet gets a higher delay, and there is a delay in playing that particular video. And as a result, what happens that at the client side you will see lots of this kind of jerkiness in quality. So, the quality sometime it good becomes good, sometime there is it is waiting for the next video frame, but it is not getting that. After that it is again immediately getting the frame, then again there is a delay. So, you will see a lots of jerkiness in the quality level, because the data which is coming from the server, it is not coming at a constant bit rate, it is coming in a variable bit rate, and that's too with a high variation. So, that is why jitter is indeed important for ensuring quality of service, so that we do not see lots of up and downs in video quality. So, in that particular context, or that particular perspective, jitter is an important parameter for consideration. And the final parameter is the packet loss. So, it triggers that how much packet loss a particular video streaming service or a particular quality of service associated application can sustain. So, certain application they can sustain a level of quality of service, but for some other applications, say for the voice application, loss is a very important parameter. So, if you have a significant amount of packet loss, you will not be able to hear the voice correctly if you are transferring the voice over the normal IP network data. Now, we will look into all these individual parameters in little details. Okay. So, first let us look into the network bandwidth. So, by definition, as you know that the network bandwidth is the amount of data that can be transmitted over a link within a fixed amount of time. Now, network bandwidth is something like we do not have much control over that. So, I actually liked very much this line by Tim Green from a book called QoS versus more bandwidth, an article. There he mentions that when a drain chronically runs low, even though it is not plugged, it is time to get a bigger pipe. So, what does it mean? That if your connection does not have sufficient bandwidth, but you require more bandwidth, then you will never be able to manage with the existing pipe or existing the line that you have. Better to go for a subscription of a higher bandwidth line. So, that is regarding bandwidth. If you have a lower capacity pipe or lower capacity network channel, you will always experience bandwidth if you are going to say deliver, or if you are going to use more amount of bandwidth. Say for example, you have a think of you have a 1 Mbps list line, and with that 1 Mbps list line you are always trying to observe high definition video. Now, high definition video, if you are trying to observe it every time, 1 Mbps may not be sufficient for you, and because of that you require more bandwidth. You need to go from 1 Mbps to 8 Mbps or even more bandwidth. Now, some applications in the network are bandwidth hungry, such as these video applications, and congestion limits per user bandwidth, and that is why we need to design networks with high capacity to improve the bandwidth. So, if you think that your application or your network is going to run applications like video applications which are kind of bandwidth hungry applications, then you purchase network lines with more bandwidth. Okay. Now, coming to delay, in network there are 3 different types of delay, or we say that there are 3 components of delay. The first one is the transmission delay, then we have the propagation delay, and the third one is the queuing delay. Now, what is a transmission delay? The transmission delay is the amount of time to push all the packet bits in the network. So, it is like that, it actually depends on the capacity of your network. So, for example, if your network bandwidth is 8 Mbps and your packet size including the packet header is 1 megabyte, then what is the transmission delay? So, 1 megabyte packet means it is 8 megabit packet, and you are transferring data at a rate of 8 Mbps. So, your network capacity is 8 Mbps. Now, if you have a 8 megabit of packet, then to transfer that 8 megabit data over a 8 megabit per second line, you require exactly 1 second. So, that is the transmission delay that we have over the network. So, it depends on the amount of bandwidth that is given to you, and based on the amount of bandwidth that is given to you, you need to transfer the data over that capacity. And the example that I have given, if your capacity of 8 megabit per second and you are going to transfer a 8 megabit of packet, that means you can transfer that 8 megabit data for 1 second. So, it will take 1 second to transfer the packet from the sender to the receiver. So, this particular delay component we call it the transmission delay component. So, this transmission delay component depends on the capacity of the channel. Now, the second component of the delay we call it as the propagation delay. So, the propagation delay is time to transfer one bit from one end of the link to another end of the link. So, usually it depends on the underlying communication bit here. Now, what is the difference between this transmission delay and the propagation delay? So, let us see it with the help of an example. Now, think of a sender and a receiver. So, this is my sender and this is my receiver. Now, the capacity, so you can think of that we have a pipe between the sender and the receiver through which you are sending data. Now, the capacity of the pipe will depend on what is the width of this pipe. So, how much data it can pump to that pipe. If you think of that the capacity of data is say 8 Mbps, the example that I was giving, that means from the sender side you can pump data to this capacity channel at a rate of 8 megabit per second. So, you can push 8 megabit data to this particular channel. So, it is depending on this capacity or the width of the pipe. Now, if you have a wider pipe, say if you have a pipe of something like this between the same sender and the receiver, where the capacity, the width is more, say it is 16 Mbps. If that is the case, that means you can push data at this pipe at a rate of 16 megabit per second. So, if your packet size is still 8 megabit, then it will take 0.5 second to push this entire data in this pipe. So, because you are increasing the capacity of the pipe. So, this particular delay to transfer or to push the data in the pipe, that we call as the transmission delay. Now, what is the propagation delay? Now, think of that you have pushed the first bit of data in the say the first bit of data has been pushed in the pipe. Now, that particular data, that particular bit need to reach at the other end. Now, the time to reach for this bit to the other end, that particular delay we call it as the propagation delay. So, whenever you are transferring a single bit, you can think of it in the form of a signal that you are transferring. Now, the signal will get propagated over this particular channel, and if the length of the channel is more, it will take more time to get propagated. So, that is why this transmission delay, it depends, the transmission delay component, it depends on the capacity of the pipe or the capacity of the channel. Whereas, the propagation delay, it depends on the length of the pipe or the length of the channel or the distance between the sender and the receiver. So, these are the two different delay components that we have, the propagation delay and the transmission delay, and there is a third delay component which we call as the queuing delay. Now, the queuing delay is an interesting component. So, the queuing delay is the delay at the interface buffer. So, whenever you are transferring certain data, during that time you have from the sender to the receiver, you have multiple intermediate routers, and these routers form a network, and you have say multiple senders which are sending data. So, you have device 1, device 2 and device 3 which are sending data simultaneously. So, assume that so another device, say device 4 which is again sending data. So, device 4 is sending some data, device D1 is sending some data, but you have certain fixed capacity of this outgoing link. Say assume D4 is sending data to D3 as well as D is sending data to D3. But at this router, say R1, you have some fixed capacity of this particular router, and because you have some fixed capacity of this particular router, the packet gets enqueued in the intermediate buffer queue or packet buffer queue that is associated with this particular router. Now, as you have more data which are coming to this router, your delay for transferring the data from this queue will increase. So, the packet has to wait for more amount of time in the queue. So, you can think of it in this way, say the packet this particular queue, it can process say one packet per second. So, if it can process 1 packet per second, that means at the outgoing link you can send 1 packet per second, and assume that you are receiving data at a rate of 8 packets per second. So, that means that every second 8 packets are getting enqueued, and that is, but the router is able to process only 1 packet per second. So, that means by the time the router will send this 1 packet in the channel, another 8 packet will get enqueued. So, you can just think of a line, a queuing line in the gate of movie hall ticket counter, say the Inox ticket counter, and people are coming at a faster rate compared to the service rate of that ticket counter. So, you have to wait for more amount of time in that particular line. So, the same thing happens here, and this particular delay component we call it as the queuing delay. So, the queuing delay is the major delay component which impacts the network. Now, in general what we have that this queuing delay, it is significantly much more than the transmission delay and the propagation delay. So, that is why the queuing delay dominates the network. Now, packet multiplexing in the network devices like the routers or the switches, it impact the queuing delay, the example that I have just shown you. Now, if you have congestion in the network means more packets are coming to the queue and it was not able to serve it. So, it increased the queuing delay. Okay, now coming to the third component which we call as the jitter. So, as we have mentioned, jitter is the variation in end-to-end delay. So, you do not have a steady stream of packets like this one, rather what you have a stream of packets which are irregulated, and there are different packets are transmitted at different instance of time, and you do not have a steady stream of packets which impacts the jitter. So, in case of video streaming, as the example that we have given earlier, this kind of jitter, it impacts significantly the application performance. So, the example that we have given earlier, that you are watching a live streaming and then packets are coming with different delays. So, it is not coming at a constant bit rate. So, the video player will not be able to play the service at a constant rate. So, it will see lots of up and downs in video quality. Okay, now coming to the fourth component which is the loss. So, this loss is a relative measure of the number of packets, or sometimes we represent it in the form of segments or bits that were not received compared to the total number of packets or segments or bits. So, this loss is a function of availability in general. If the network is available, that means if your capacity is more than the demand, then the loss will generally be 0. You do not see any loss there, but if your capacity is less, then you will see significant loss from the network. So, that is why whenever there is a congestion, you will see there is a significant loss, and that is why TCP takes that loss as an indication of congestion. But this particular principle does not hold exactly in case of wireless network, because in case of wireless network there can be loss from the channel as well, like you are transferring the data in an open media, and that is why you can just think of that lots of people are talking together in a single room. If lots of people are talking together in a single room over that open environment, then it will create a noise and none will be able to hear other voice. So, the same thing happens in case of wireless media, what we call as the interference. During the discussion of wireless physical layer, we will talk about this interference in more details, but this interference is also results in packet loss. So, in wireless there are multiple results, multiple reasons for packet loss, or indeed that is the reason you will experience more amount of packet loss in a wireless environment. Okay. So, if we look into the application level quality of service, so different application requires different level of quality of service in terms of delay, jitter and bandwidth, and here is an example chart for that. So, you can see that for the voice application, so this data is taken from Cisco, a typical networking company. So, the voice data has a loss tolerance of less than equal to 1%. You need to, it can tolerate very few losses. The delay should be less than equal to 150 millisecond, the jitter need to be less than equal to 30 millisecond, and you require some 21 kbps to 320 kbps of dedicated bandwidth. For interactive video like the live streaming, the loss need to be less than 1%, the delay can be around 150 millisecond, the jitter need to be 30 millisecond, and the bandwidth is on demand. Like if you are watching a high quality video, you will require high bandwidth. If you are watching a standard quality video, you may require little less bandwidth. For the streaming video, like the video that you are watching right now in YouTube, where the video has been pre-recorded and now getting streamed, it can sustain more amount of loss. Why it can sustain more amount of loss? Because the video is already recorded. So, that is why, say for example, you have received frame 1, frame 2 has lost, and you have then received frame 3. Then by doing averaging over frame 1 and frame 3, you can recover certain part of the frame, the lost frame, because it is just like images, frames means images one after another. So, that is why it can sustain for more amount of loss. The delay is equals to the buffer time at the client side. Jitter is again depends on the buffer time, and the video is on demand. If you are going for high definition video, you will require more amount of bandwidth. For normal data transfer, we do not have any bound on loss, delay or jitter, and the bandwidth is the best effort, the best bandwidth that you can support for that application. Okay. So, here is the formal definition of quality of service, which is coming from Cisco. So, I have highlighted the different part of the definition in different color, the important keywords. So, quality of service refers to the capability of a network to provide better service to selected network traffic. Why it is selected network traffic? Because we are looking into network traffic which are quality of service associated, like the voice traffic or the video traffic, over various technologies including frame relay, asynchronous transfer mode, Ethernet and 802.1 networks, SONET and IP based networks. So, you need to remember that whenever you are trying to transfer data from a one end host to another end host, say this host is in India and this host is in US, in between you have multiple such links, and different links may be of different types. Say the first hop may be wireless, then the second hop may be Ethernet, the third hop may be optical network like SONET. So, you can have multiple networking technologies in between. So, you need to provide quality of service over multiple technologies. IP network that may use any or all of these underlying technologies. So, the primary goal of quality of service is to provide priority including dedicated bandwidth for certain classes of traffics, control jitter and latency. Latency means one way delay required by some real time and interactive traffic, and improved loss characteristics. So, this is the formal definition of quality of service. To ensure quality of service over a packet switch network, we need to find out these 4 different things. First of all, what the application need from the network, what type of quality of service it is expecting, how to regulate the traffic that enters the network to provide quality of service. We will look into all these things in details in the subsequent lectures. Then how to reserve the resources at a router to guarantee performance, because you need to have end to end dedicated resources to ensure certain classes of quality of service, and whether the network can safely accept more traffic while not violating the quality of service of the existing traffics. So, the primary quality of service parameters that we have already seen, there are 4 such parameters: the bandwidth, delay, jitter and loss. So, in terms of quality of service, many of the time we will use this term flow. So, this flow is a stream of packets from a source to a destination. Now, when we call as a source to destination, there can be multiple such definitions. It can be a machine to machine communication. So, we want to ensure quality of service between 2 machines. It can be process to process communication, like we want to provide quality of service between 2 different processes when they are communicating with each other. We may want to ensure quality of service from application to application or from socket to socket, or different ways we can define the 2 end of a flow. Now, different flows require different levels of quality of service, and accordingly we need to provide quality of service to those flows. Now, another important question is that why quality of service is considered at the network layer? Because maintaining quality of service requires both per hop and end to end behavior. So, whenever you want to ensure quality of service over the network, say you have these two different end hosts, and between these two different end hosts you have multiple intermediate routers or switches. Now, what you have to do, you have to see that what is this end to end requirement to ensure quality of service, what end to end bandwidth you want to ensure, what end to end delay you want to ensure, what end to end jitter you want to ensure, or what end to end data loss you want to ensure. But to ensure this, you have to reserve the resources at every individual hop of the network. So, to guarantee quality of service, you require this per hop behaviors, or you need to reserve the resources at every individual hops in the end to end path. So, that is why we need to consider quality of service by considering the information from end to end perspective as well as per hop perspective. Now, if you look carefully, this network layer, it sits in between the transport layer and the data link layer. So, the data link layer considers per hop behaviors, and the network layer provides you this routing over that individual hops, whereas the transport layer, it gives you the end to end information. So, you can get a feedback from the transport layer and apply the things to the data link layer. So, that is why you implement quality of service at the network layer. So, that is the point I have just mentioned. Resource reservation need to be on per hop basis, otherwise end to end requirements cannot be guaranteed, and because the network layer bridges the end to end like the transport layer and per hop the data link layer, we implement quality of service at the network layer. Now, based on the quality of service, we define multiple application classes like the constant bitrate classes. So, example of constant bitrate is telephone applications like voice over IP. So, you require constant streaming of data bits. Then the second one is the real time variable bitrate. So, in case of real time variable bitrate, example is some video conferencing service where the bitrate can be variable depending on the frames that you are going to transfer, but it need to be real time. The third one is non-real time variable bitrate like on-demand video streaming. So, for example, television service over IP network. So, if you want to observe a TV over a IP network, it is a variable bitrate. At the same time, it need not to be in real time. And then available bitrate service or the best effort service like the file transfer services. So, we will look into all these classes of traffic in more details, and in the next class we will look into that considering this different level of quality of service or different classes of quality of service, how the network should design itself so that it can provide the desired level of quality of service. Hopefully, you have got a basic idea about what quality of service means, and in the next class we will go to the details about how the network actually provides quality of service in the internet. So, thank you all for attending this class.